Hello, continuing to look at examples from Chapter 6.4 in Block 5 textbook. All right, I want to look at example 2, Diet Coke and calcium. The general research question is, does Diet Coke wash calcium out of our systems? So a study was done to investigate this question. Randomly assigned 16 healthy women to drink 24 ounces of either Diet Coke or water. That's a lot of soda. Anyway, the urine was collected 3 hours after they drank the Diet Cola or the water. And in the urine, their calcium was measured. So for the 8 Diet Cola drinkers, the mean calcium excreted was 56 milligrams, standard deviation of 4.93. And for the 8 water drinkers, the average calcium excretion was 49.1 milligrams, standard deviation of 3.64. Okay, so we need to figure out if we use the T or Z distribution. So I want to write here a note, we only know sample data. I'll write down what that means. We have an overline x bar, I should say, for, I'm going to use C for cola, is equal to 56. And standard deviation, S subscript C, I'm going to use for cola, was 4.93. And N sample size, subscript C is 8. And then we have X bar here for the water drinkers was 49.1. And here the sample standard deviation for the water drinkers, S is going to equal to 3.64, and the sample size, N sub W, is also 8. All right, so we only know sample data, sample mean, sample standard deviation, so we need to use the T distribution. All right. Okay, so then I want to know what assumptions need to be made in order to use the T distribution. So I'm going to go to the inferential statistics formulas, offer means proportion for chapter 6. And on the second page of this are the requirements or assumptions needed for using the particular inferential statistics, hypothesis testing, confidence intervals. Here we're looking at difference of means. We're looking at the average amount of calcium excretion for Diet Cola drinkers versus water drinkers. And we need to have either sample sizes of at least 30 or both population distributions need to be assumed to be normally distributed. So notice right here, our 2 sample sizes are fairly small, 8 and 8. Those are both less than 30. So since both sample sizes are less than 30, we need to assume the population distribution of all calcium excretion. A woman, after drinking water or Diet Cola, is approximately normally distributed. Again, we could use the approximately. We have to make this assumption anyway, so we need to assume the population distributions are normal. And there are tests from your data to check to see if your sample comes from a normal distribution. And those tests are actually not going to cover this class. They would be second semester statistics. So for right now, I do want you to know those requirements or assumptions. So you need to get large enough sample sizes, or both populations, we need to assume both population distributions are normal. All right, so find and interpret a 95% confidence interval, the difference in the mean amount of calcium excreted between Diet Cola drinkers and water drinkers. Okay. All right, so I want to go through this 2 different ways. One, using the formulas, and then I'm going to go over to stat key. So first thing I want to do is I want to write down the formula. It's right here. Note we use 7 degrees of freedom. In this case, because both sample sizes are 8, degrees of freedom is n minus 1. And the confidence interval formula right here, I'm going to take statistic plus or minus t star times the standard error. And what is this actual value? In this case, the statistic is going to be use x bar c minus x bar w plus or minus t star, and then we would multiply the square root of, in this case it would be s sub c squared over n sub c, and then plus s sub w, standard deviation of all the water drinkers, squared divided by n sub w. Alright, and if we were to plug all this in, this would be identically equal to 56 minus 49.1 plus or minus t star, actually I'm going to write this down, 2.364, and then we're going to multiply this times, if we're going to plug this all in the formula, it would be 4.93 squared divided by 8 plus 3.64 squared divided by 8. All right, so maybe I'll throw this in parentheses. It's kind of easier to see. And we can throw this in a calculator. I do want to make a very quick note. How do we get this t star? T star is 2.364. If you want to get this t star, we're looking at a 95% confidence interval. So if I go to stat key, here, click on T for theoretical distribution. We're in 7 degrees of freedom. Click on two tail. Make sure I have 0.95 in the middle. And here we get 2.365. Oops, so again, a little typo. That should be 265, not 264. All right. And we end up getting, goes through calculator, approximately 6.9 plus or minus 5.122. And if we write this down, so the 95% confidence interval is between 1.778 and 12.022 milligrams. I might want to double check my calculator. This might be slightly off, maybe the third decimal. The process here is correct. And I want to interpret this in a second. Before, I want to go in and say we don't actually have to use this formula, as long as you're okay with using GeoGebra. GeoGebra screen here. I'm going to click on statistics. I'm looking at a z estimate for confidence interval, difference of proportions. Or sorry, no. Difference, t estimate, difference of means. 95% confidence. In this class, we're never going to click on pooled, so make sure that's unclicked. And now I need to enter the mean, 56. Already had that. Standard deviation, this is the COLA group, 4.93. Sample size 8. For sample 2, I have 49.1. Standard deviation 3.64. Sample size 8. And notice, I need to make this a little bit smaller. We get the interval down here, 6.9 plus or minus 4.685. But if we look at the actual interval, lower estimate 2.125, 11.585. All right, so yeah, looking at GeoGebra's results, entered in all the data to GeoGebra, t-estimate difference of means, 95%. I have noticed, I've gone through the homework assignment, that there is a little bit of a difference here. So here it gives the confidence interval to be, 2.215 to 11.585. When we computed this through the actual formula, we got the confidence interval to be 1.778 to 12.022. All right, so there is an issue with using GeoGebra for a t-test of a t-estimate, difference of means, if the sample sizes are fairly small. So I went through the entire homework assignment for 6.4. If the sample sizes were roughly 30 and up, the Wiley accepts either. You either use GeoGebra or this formula. So for sample sizes less than 30, you need to use the formulas for Wiley homework. I actually messaged GeoGebra to find out why there's a discrepancy. From what I can tell, GeoGebra is actually incorrect for these small sample sizes. Or maybe they're doing some different formula. So I'll try to find out what's going on with that. For your project and the test, I'm okay with GeoGebra or the formulas. And I'm going to try to, on the Wiley quiz, the last quiz we'll do in a couple of weeks, I'll pick problems that have large enough sample size, and I'll make sure you could use either. And I'm also going to drop, I think I've decided upon 6 homework assignments. Again, because there's a discrepancy here, I'd like you to be able to use GeoGebra or the formulas, but there's a discrepancy in chapter 6.4, unfortunately. So if we stick with the formulas, confidence interval, 1.778 to 12.022, we would say something about we are 95% confident that Diet Cola drinkers excrete calcium on average between 1.778 and 12.022 milligrams more than water drinkers. So does Diet Cola appear to have an effect? So Diet Cola does appear to have an effect, calcium excretion. All right, in the next video, I want to go through a confidence interval. I'm going to go through confidence interval fairly quickly just to make sure that this matches up exactly what we want. But I will do that in the next video.